quite a few minutes in. But that's okay, that was more important. All right, this was the little tiny bit of the section we have left. Oh, Marvel, that fits you very well. I can't, you kind of reminded me of like an old-time barber or like an evil mastermind or something.
Yeah.
I like it. So this may look scary depending on the notation to you. I feel like I kind of told you what this was yesterday, not positive, but you can keep taking derivatives. So like our normal equation, if you take the derivative, it tells you how fast the equation changes. That's why it's slope. But then we can take the derivative of the derivative, and that's going to stand for how fast is the slope changing. Bless you. And that'll look like curvature. Then you can take the derivative of the second derivative. In physics, this would be torque. You can keep taking the derivative and keep figuring out how fast things change. I have literally never seen anything past a third derivative stand for anything, but I'm sure it does. So you can just keep taking the derivative, and this is how they denote it. First derivative, which we've done, is the prime. Each derivative after that, they add another apostrophe. So second derivative, third derivative. And then instead of making it super annoying and just counting tick marks, then they decide to start just writing the number. But like I said, very seldom have I ever even seen this or used it or anything other than teaching it. So that's our goal here. We'll do this first one together, and then I'll move on to weird ones like that one and that one. Okay, so it says find second derivative. That requires us to find the first derivative. So 3 halves times 3 would be 9 halves x, and then 2, yeah, subtract 1. Now we have 10 x to the first, and then the derivative of minus 6x is minus 6. Derivative of 1, 0. Okay, now we're going to do the derivative of that line. I mean, like finding multiple derivatives isn't more difficult as long as the equation is normal. As soon as you start having a crazy equation like a fraction, like quotient rule, taking the derivative of a quotient rule answer can be horrible. In fact, you really can't even do it yet because you don't know all the properties and rules and stuff yet, so we won't be doing that for now. So second derivative of this one, 9 halves times 2. 9. X, subtract 1 would be x. 10x is 10. Okay, good. That's the answer. And then you could probably see that on a polynomial, if you keep taking the derivative, it's just going to turn to 0. And you could keep taking derivatives, but they're all zeros. Okay, C. The 32nd derivative. No work, no problem. Okay, so sine of x is, we'll call that f. We'll signify this with notation. This isn't as bad as it seems because sine and cosine are their own derivative. So the first derivative would be cosine. Second derivative would be second derivative. Negative sine. Third derivative, negative cosine. the fourth derivative starts repeating. I wrote 4, whatever. I should have just put a 4. But yeah, it turns back into positive sine. So sine and cosine derivatives are cyclical. They go in cycles of 4. So I wrote this up here to help you figure out the pattern. So it obviously is multiples of 4 in a sense. This one says 32nd derivative. What would they be the answer?
Sin is x.
Yeah, this 32 would be the direct multiple of 4. If this said 35th derivative, then I would know it would be the third one, because 36 would be the correct next multiple. So you just kind of use the pattern to figure it out. So d32, dx32 of sine is sine. Time-wise, do you want me to do D with you? Should we do that one? Should we skip that one? Do that one? Oh, all right. I didn't know how much time you wanted to work, so that's why I asked. So I need to figure out the pattern. So this is 0, first derivative, negative sine, second derivative, actually those little dots with me, negative cosine, third derivative, positive sine, and then this is when it cycles, fourth derivative, let's start with cosine. Okay, so now we have our cycle. Now I need to figure out 867. We need to figure out which multiple of 4 or how that compares to it. So divide it by 4. 2, 1, 27. Actually, 5, I think. 6. And then remainder 3. Okay. If it divides evenly, that would be the 0 or the fourth whole multiple. Your remainder tells you which one of the other 3 it would be. So because I have remainder 3, means it's going to be this one. If it would have been 868, it would have divided perfectly evenly and been a multiple of 4, so then it would have been the top one. But the remainder tells us which one of the other 3 it is. So the 867th derivative is sine. So you kind of just use the multiples of 4 to figure things out. Now, before we do the bottom problem, do you want me to leave this up here? Is anybody still copying it? Sure. I feel like I should get an old monitor that doesn't work so I can recreate Ron's once it's from the computer. That'd be kind of fun. Got it? Mm-mm. Is that right? It's been a while since I wrote it. You guys, wait, hasn't physics done this yet?
What is that? Yeah.
Or taken it last year? I think that's the
Yeah.
position function, right?
Yeah.
Okay. So 1/2 acceleration due to gravity times time squared plus initial velocity times time plus initial height or position. So this is the free fall formula. So if you want to find the height of an object due to gravity, this is the height of an object. That's all it finds. It does not find like horizontal movement. This would just find its vertical height. If I take a derivative, one half and a are numbers. T is the variable. I mean, it said so because of the way they write the function. So this would be 2 times 1/2 at, so that'd be a. And then t, I would drop down a power. V0t is like saying 5x. The derivative of 5x would be 5. So the derivative of V0t is V0. Derivative of initial height would be 0. So this is position or distance, whatever you want to call it. This would be the change in distance, which is the velocity formula. So this is kind of how they came up with the velocity formula. And then, if I do the second derivative, we're talking about how fast velocities are changing. That's going to be acceleration. And the derivative of at is just a. Derivative of v0 is 0. I believe, don't they teach you all 3 of these? Or do they just teach you position? Somebody take physics last year? Really? You took it last year? Do you remember if they taught you all 3 of these? I feel like they did. Just position?
We were, yeah, the second equation.
For velocity?
Yeah.
Okay. Now, I don't know if this is mind-blowing to you or if it's just kind of interesting. What's actually stranger is that when we get to the second half of Kelp, second trimester, probably second trimester, maybe third, this wasn't discovered by doing derivatives. So, I mean, you all know the story of Isaac Newton with the apple and stuff, right? Or Chicken Little, whatever. So somebody measured acceleration due to gravity. That was it. That's all they did. They started with acceleration. They figured out how fast something fell. I mean, the story is supposed to be Isaac Newton measured the apple because it saw it falling and he realized it fell faster at the bottom than it did at the top. So that was acceleration. And so somebody measured acceleration. We're going to learn antiderivatives, which is going to be called integration. And so somebody just measured this, and then they do the reverse derivative, came up with this equation, and that's where this equation came from. So they figured out how to find velocities at any time. And then they did the reverse derivative and came up with the position function. So if you're ever in class and looking at a crazy equation like this, and you're like wondering how on earth would somebody come up with this formula, they actually didn't do any kind of measuring or anything. They started with just a single number, and then they figured out the formula and reverse engineered it. They worked it backwards.
What happened if you did the reverse derivative? Kept going.
You can. Does it stand for anything? No. It's only because acceleration is kind of, like when you measure acceleration, it's feet per second squared. So the second squared portion of that kind of determines how many reverse derivatives you can do. So it kind of depends on what you're starting with. So yeah, you can keep doing it, but it doesn't stand for anything. It's like if I did the 10th derivative, it's worthless. It doesn't actually do anything. Okay, I wanted to show that first because there's a question here that talks about position, and then it brings up velocity without saying anything about how to figure Don't be putting that on other people. You are disrespecting the mustaches. It looks so good on you too. Why'd you rip it off already?
I can only smell the glue.
Oh, that's fair. Yeah, I'm sure that doesn't smell great. Okay, a potato launcher. FYI, we are very close to my favorite story problem in the entire packet. The beginning of the next section is my favorite story problem. So this is a good week. We have Movember starting today. Tomorrow, we have my favorite story problem in the entire packet. Not the potato launcher. This just reminded me of it because this was kind of fun. Potato launcher fires a potato downward from the top of a 112-foot tall building. The potato hits the ground in 2 seconds. Find the initial velocity of the potato. The position function is given as this. So they give this to you. This tells me that they used negative 32 feet per second squared. Meters is traditionally what you use in physics. So they give this to you. We're trying to find V0. So it says where distance S of t is in feet and time t is in seconds. Oh, anybody have any thoughts? So this gives us position. Okay, we can. So this is velocity. I suppose I could just write velocity. You said put 0 in for time? I forgot what you said. Yeah, 100% that would work. However, what does that give us? V0. So it doesn't help us find the answer, but it absolutely is correct. So like what you said fits it. If I put 0 seconds in, 0, it's actually what V0 stands for. Velocity at time 0. So it basically just verifies it says correct. But that was a good thought. What does that do? Okay, put 0 in here, I would get the initial height. Which is okay, because they actually already told us that. But that's a good thought too. I think where you guys are sort of getting at, I knew yours, because yours was correct. Yes. So the 0 I think you were thinking about is actually the height. This whole function stands for the height. So you would put 0 in place of S of t. So the height is 0 when the time is 2 seconds. So if we read what it tells us, hits the ground is code keywording for height of 0. And 2 seconds was time 2. Now, I realize I was probably misleading you with the derivatives because that's where you went first. This particular one, we actually can figure out without doing any work. But I wanted to show you the derivative stuff because that is 2.7. And that is what the entire next section is. So this problem is here as kind of a gateway to like position, velocity, acceleration, sort of get used to that. I have no idea what the answer is. Negative 64 plus 2v0, 112. Oh. 58. If I add those together, is that 58? So V0 is going to be 26, negative 26. Let's just go with Owen. Why is it negative? That feels like it should be wrong.
Because it's going down.
Perfect. Velocity has a direction, so a positive velocity would mean you're shooting it up in the air. This one, it tells us they're shooting it downward. So the downward velocity would be negative 26 feet per second. That's because I'm good at math. That's what I wrote in the first place. Now, what's partially weird about this problem is it doesn't bring it up. This one, it says you fire a potato launcher downward. It actually 100% means straight down. Most people would not do that. Most people would probably fire it at an angle or something. This information would only stand for the current height of the potato, nothing about how far away it would be.
Maybe 48, negative 48.
Am I just doing really bad at this? Wait, no.
The answer would be.
Yeah, minus 24, but like the first part where it's 112 minus 60.
It'd be 48 instead of,
Oh, not 58?
Yeah.
it's 48.
I was doing 122 in my head. Wait, somebody backed me up on 58 though. So I had the final answer right even though I screwed up. No, I had 26. Okay, it's all right. Third answer. Third time's the charm. Apparently I'm allowed retakes and corrections as well. This is just leading us towards the next section now, talking about position, velocity, acceleration. Almost all of your work is going to be on derivatives, whether it's trig, whether it's multiple derivatives, product rule, quotient rule. What time did we get done today? Today's a full day, 27. I wanted more time, but I mean, this is still at least some time to work. I wanted you to have a chance to be able to ask me questions. I put the answer key attached to the assignment now too, so you guys can check how the answers should look. I purposely wouldn't help some of you yesterday because you were asking me if you were simplifying it far enough. And I understood why, but I wanted you to try to simplify it as far as you could on your own. So feel free to check the answer key to see if you match up with it, and I can help you with whatever. So about 20 minutes of doing that. I suppose if anybody has anything to turn in, I can put that in too. That tiring? And yes, if you don't want to wear the mustache, it makes a great cover on your calculator or covering the camera on your Chromebook. You know, some people are all paranoid about that, so. However, your Chromebook doesn't shut all the way, but still.
Looks good.
Yeah, that one fits you better. The thicker one fits you better.
I have a question. What's the last time we take this most previous test?
That's the best.
Yeah.
Because I forget when you handed it.
I believe I handed it back. Actually, I'm pretty sure this is the second week.
So you think it's tomorrow?
Oh, you can still retake it tomorrow, yeah.
But tomorrow's the last day.
Tomorrow's the last R&R day. It's not the last day.
Yeah.
Yeah.
But like.
During school hours, yeah.
So what's the last?
I believe the last day to do it would be Monday. I think I handed it up on Monday of that short week.
Are you? Can I come in before school or after?
Yep,
After school?
yep,
Yeah. You have hours.
yep. I mean, I don't really go by the official hours. I'm in here when I don't have a meeting. I have to post some because the school makes me, but
I'll email you or whatever.
yeah, just ask which one, if it works, and I can let you know.
Yeah.
after.
Oh, I got to square root of times negative cosine
Who, what?
square theta minus cotangent theta times half theta to the